Question number 29. A point P moves on the plane x by a plus y by b plus z by c equal to 1, which is fixed. A plane through P perpendicular to OP meets the coordinate axis in A, B, and C. The planes through A, B, and C parallel to YZ, ZX, and XY plane intersect in Q. Prove that if the axis be rectangular, the locus of Q is 1 by x square plus 1 by y square plus 1 by z square is equal to 1 by ax plus 1 by by plus 1 by cz. Pretty long question. Okay. Now we have a plane x by a plus y by b plus z by c equal to 1, which is fixed. That means this a, b, c are fixed points. So now let's assume PB alpha, beta, gamma. This is let P be this. Now we know that point P lies on this plane. So we'll just write down the plane itself, x by a plus y by b plus z by c equal to 1. Call this as 1. Equation 1. So P lies on 1. Therefore, we have alpha by a plus beta by b plus gamma by c equal to 1. Will be we have this relation between alpha beta gamma in terms of ABC. Now a plane through P perpendicular to OP. So perpendicular to OP, to any line OP. So if you know, direction ratio of line OP will be 0 minus alpha, 0 minus beta, minus gamma. Or we can take negative alpha minus 0, beta minus 0, gamma minus 0. We can take that also. Or we can say alpha, beta, gamma. These are the direction ratios. So direction ratios of line OP will be alpha, beta, gamma. And it is said a plane through P perpendicular to OP. So normal, if we have a point P and a normal, we can write the equation of a plane passing through P alpha, beta, gamma, and a normal and a plane through P perpendicular to OP. OP. Plane is perpendicular to OP. That is normal. Normal of the plane is OP. So such an equation is given by alpha direction cosine to x minus alpha plus beta into y minus minus beta y minus beta plus gamma into z minus equal to. So alpha, beta, gamma is the direction ratios of the normal to this plane, which we already found out as alpha, beta, gamma. So we have this now, and it is that a plane through P perpendicular meets the coordinate axis in ABC. So if this plane meets the coordinate axis in ABC, we can find what ABC is. So if we'll call this equation 3 meets coordinate axis at putting y is equal to 0 and z is equal to 0, we get alpha into alpha minus beta square gamma square equal to 0, which gives alpha x is equal to so a is, we got our a as alpha square plus beta square plus gamma square by alpha 0 0. Similarly, you can find out b is nothing but 0 alpha square plus beta square plus symmetric beta, and c as 0 0 alpha square plus beta square. Right. So we got our ABC. Now we need to find the planes through ABC and parallel to the coordinate planes. So we earlier, if we have points like this, we did discuss it earlier. We have a point A 0 0 and draw a plane like this parallel to say here y. Such a plane will have equation x is equal to, and similarly if we draw a plane like this, have equation y equal to b. Similar parallel to coordinate a given point C, we'll get z. Instead of a b c, we have these points, so we can write plane passing through A and parallel to yz plane. X is equal to alpha square beta square. Similarly, plane passing through B parallel to that plane. Y equal to parallel. Now we have these three planes. Now we need to find the locus of the point of intersection. So the planes through ABC parallel to YZ coordinate planes intersect in Q. Through that the axis be rectangular, locus of Q. We are to find the locus of Q. So locus of Q is nothing but an equation which satisfy different values of Q. Different all the intersection points that should satisfy that locus equation. That is the meaning of locus equation. So intersection point you should say if Q is, so let's assume Q is x, y, z, then it should satisfy these three equations 4, 5, 6. And these three, when it satisfies this equation, if you see, alpha, beta, gamma are changing variables. So alpha, beta, gamma changes, um, changes, but the here alpha, beta, gamma is point P which changes, but this plane is constant. So A, B, C is constant. So we need in our locus equation we shouldn't have alpha, beta, gamma, but we can use instead we should eliminate this alpha, beta, gamma in terms of A, B, and C. So that is what we are going to do. Since the equation is a little tough, complicated, we will be using this part. It is already given. We have the equation, and we just have to prove that this 1 by x square plus 1 by y square plus 1 by z square will be nothing but 1 by x plus 1 by vy plus 1 by cz. Given x, y, z are the represent locus different points of Q. So for that, we just need to we will check RHS, LHS, and RHS separately. So using 4, 5, 6, we have 1 by x square plus 1 by y square plus 1 by z square as, from this equation, 1 by x square plus 1 by y square plus 1 by z square can be written as alpha square by alpha square plus beta square plus gamma square the whole square plus beta square by alpha square square square. So instead of x, y, z, we this equation substitute. So we got this. This is nothing but, you simplify, alpha square plus beta square will divide with now we need 1 by as, sorry, using again 4, 5, 6, one by ax plus 1 by by plus 1 by z, 1 by x plus 1 by vy plus 1 by cz as. So here 1 by ax, so inverse of this and multiplied with a. So we have a alpha by alpha square plus beta square plus gamma square. Sorry, not a alpha. This is 1 by x, and we need a here plus beta by so if you group, if you take alpha 1 by alpha square plus beta square plus 1 by gamma square outside, get alpha by plus beta by c. So but from equation 2 we know that alpha by a plus beta by b plus gamma by c is nothing but 1. So using 2 we have 1 by ax plus 1 by b equal to 1 by beta square. So let's call this. Now you see, using 7 and 8 we can say that, using 7 and 8 we can say that 1 by x square Now we have the relation between x and a terms in it. Let's the question. So we get the locus of q as 1 by x square plus 1 by by plus. I hope this is clear. If you do steps, solution to question 29.